Hi there grade 9s and welcome once again to WorksheetCloud Maths. As you can see, I'm in Joburg and it's pretty chilly. I hope where you are the weather is fine. If you are in Joburg, I hope that you are wrapped up warmly so that you can enjoy today's lesson. Right, let's get going. We're going to do some revision of our geometric figures today. We've done a lot of theory and a little bit of practice around our geometric figures, and now we're going to put some more into practice. Okay, we're going to start off by constructing a line that is perpendicular to another line. So AB is going to be perpendicular to MN. Remember how we did it before? We used a compass. We drew a line. We put point A on the line. Let me just move myself up. Put point A on the line. Put our compass point on point A. And then we drew arcs on either side. Okay. Make your arc about 3 centimeters and then you'll make it 3 centimeters on the other side. Right. Then we're going to draw 2 arcs above the point A, and so that they cross, and we will join that with a line and we will call it B. Okay, so you can see I've named my 2 arcs MN, and where the line has joined where the arcs cross, that is B. So it means that AB is perpendicular to MN. Okay, we're going to go one step further. We're going to now draw an arc up 4 centimeters from point A, and we're going to name it point C. As you guessed it, the next thing we're going to do is we are going to join C to N, and you can see now I have got a triangle, and I've got a side of 4 centimeters and another side of 3 centimeters. Remember in the last lesson we looked at the Theorem of Pythagoras. We are now going to practice that. We did do a little bit of practice on that last time, but let's see how we do this. Okay, if AC, that line, is perpendicular to MN, that line, and AN, that part, is 3 centimeters, calculate the length of CN. Okay, we know that CN is the hypotenuse. And so the other 2 sides are 4 centimeters and 3 centimeters. We can now work out the hypotenuse because of the Theorem of Pythagoras. Okay, so here we go. Remember the theorem states that the hypotenuse squared is equal to the sum of the other 2 sides each squared. So it's going to be CN squared is equal to 4 centimeters squared, or AC squared, plus AN squared. Okay, so that now you can substitute in. CN squared, we don't know, but we do know what CA is. It's 4, so it's 4 squared plus 3 squared. Okay, AN 3, and we have to square it. Okay, we can leave out the centimeter sign because if we write 4 centimeters squared, we haven't really squared the 4, and so algebraically it doesn't really work. Okay, so what we would have to do is we're going to square 4 squared, we're going to square 4, we're going to square this 3, we're going to add them together, so it gives us 16 plus 9, gives us 25. We're then going to find the square root of 25 to give us CN, and the square root of 25 we all know is 5 centimeters, which means that the hypotenuse in this triangle is equal to 5 centimeters. Okay. Let's have another look at something else. We are given a rectangle ACEF, and we need to calculate the sizes of the following angles. Okay, there's our rectangle. We know it's a rectangle. We've been told it's a rectangle. But another way you can see is that we have 2 angles here that are 90 degrees. If those 2 angles are 90 degrees, it means that that line is parallel to that line, and it means that that line is parallel to that line. We can see that our 2 sides, our opposite 2 sides, are equal in length. So we've got 2 long sides and we've got 2 short sides. Okay, now we have to calculate the sizes of these angles, and they are found in our rectangle. So let's start. The first one we're asked to calculate is F1. We need to locate F1. Here it is down here. Okay, we know that the whole of F is equal to 90 degrees. So F1 must be 90 minus 60. And our reasoning is because all angles in a rectangle are 90 degrees. Okay? the answer to that would be 30 degrees. Right. The next one we have to find is B1. Let's locate it. Here it is here. Okay. That is a quadrilateral. It's an irregular quadrilateral, but it's a quadrilateral no less. And the angles in a quadrilateral equal 360 degrees. So to work out B1, we would say 360 degrees minus the angles we know, which is 60 plus 90 plus 90. 90 plus 90 is 180, plus 60 is 240. 360 minus the 240 is 120 degrees. So that angle there is 120 degrees. We now have to work out B2. As you've guessed it, it's angles on a straight line. So let's have a look. We've got 180 degrees minus our 120 degrees from here. That gives us 60 degrees at B2. And reasoning again is angles on a straight line. There we go. All right. Are you still with me? Okay. Let's have a look at D2. Let's locate it. It's over here. We now know that that's 90 degrees. We know that that's 60 degrees. So we can work out that one with, as you guessed it, angles in a triangle. So we're using a lot of the theory that we've done over the past couple of lessons. So we're going to go 60 plus 90 is going to give me 150. And then 180 minus 150 will give me 30. The last angle we have to work out is D1. And as you can see, we worked D2, which is giving me 30, plus we've got 90. So to work out D1, we're going to use angles on a straight line. Okay, so 180 minus 30 plus 90 gives me 120. 180 minus 120 is 60. I hope you can see that down there. It's hidden a little bit. Okay, let's look at the next thing. Okay, we now need to calculate the length of the sides. In this diagram, we've got FH, there we go. We've got RJ, that's that one. We've got GH, which is that one. And then we've got RG, which is that whole one there. Okay, this is a rhombus. The reason that we know it's a rhombus because we are told that all four sides are equal. Okay, we are given JH's measurement as being 16 and RH's measurement as being 20. Okay, so let's have a look. FH is this whole diagonal, and we know that FH is 16 times 2 because diagonals in a rhombus bisect each other. So we know that this half of the line is equal to that half of the line. So that 16 plus 16 is going to give me 32 centimeters. Right. The next one we have to work out is RJ. Okay. RJ over there is JH. Let me just work it. JH squared plus RJ squared, because that there the diagonals bisect at 90 degrees. That is one of the properties of a rhombus. Remember, we do not have angles at the vertices being 90 degrees. So where our diagonals bisect, that's 90 degrees, which means that RH is actually the hypotenuse. Okay, but we're given JH and we're given RH, so we have to work backwards. All right, let's have a look. Here we've got 20 centimeters squared, 20 squared, is equal to the 16 squared plus the RJ, which we don't know. Okay, which means that we can work it out. 20 squared is 400, 16 squared is 256, and that we don't know RJ, so we just still write RJ squared. We can then move our 256 across the equal sign and say 400 minus 256. That gives me 144. Nice figure to work with if we are square rooting, because we should all know that 144 square rooted is going to give me 12. So RJ, that line there, is 12 centimeters. Okay, let's just go over it again. We know that our diagonals bisect at 90 degrees. So even if we don't know that line, if we don't know one of the lines, we can work it out using the theorem of Pythagoras, or Pythagoras theorem. Okay, we can just abbreviate it as being Pythag. Pythagoras is quite a mouthful and quite a long word to write, so we just get a little bit lazy here. Okay, we know RH is 20 centimeters. We know JH is 16 centimeters. So the hypotenuse squared is equal to the sum of the other two sides squared, each squared. Okay, so it's 16 squared plus RJ, which we don't know, but that is squared as well. So we're going to go 400, which is the 20 squared, 256, which is 16 squared. We're going to say 400 minus 256, which is going to give me RJ, my unknown side. And that's 144, but we have to square root that. We square root both sides, so we get RJ is equal to 12 centimeters. Okay, hope that didn't confuse you too much. We now have to work out GH. Guess what? We're going to work out sides of a rhombus. This is easy. I'm sure you picked that up straight away. There's nothing to actually work out because GH is the sides of a rhombus, and the sides of the rhombus are all equal, so GH is 20 centimeters. But if you wanted to do a lot of working out, you could have also done Pythag, I suppose, because you have got RJ is equal to JG because the diagonals bisect each other, which means that JG would also be 12 centimeters. You could then work out the length of the hypotenuse and you would get 20 centimeters. But that's quite a long way around, so it's fine to say we know that a side of the rhombus is 20 centimeters, so all the sides of the rhombus are going to be 20 centimeters. The last one we have to work out is RG. You've worked out RJ, and RJ is actually half of that whole diagonal. So RG is equal to RJ times 2, which is 12. We worked it out over here. That's 12 centimeters times 2, and it's going to give me 24 centimeters. Okay, it seemed like quite a lot to work out, but actually that was your biggest working. Once you had that, you were able to do everything. Okay, right, let's go on. Okay, now we've got to calculate the value of x in that diagram. Let's see, here's x down here, right? We now need to calculate this value, but we are only given that value there. Okay, the other thing that we are given is that this is an isosceles triangle. So let's have a look. Okay, the first thing we're going to work out is B1, and that's angles on a straight line. So you guessed it, it's 180 minus 128, and that is going to give me 52. So that angle there is 52, which means that because of these two little lines that are here for us, that means the isosceles triangle, the two base angles are equal. So if we know that angle, we're going to go 180 minus that angle divided by 2. So let's have a look. D1 is going to be, remember, angles in a triangle, going to give me 180. We're going to minus the 52 of the one that we know, and what is left we are going to divide by 2 because those two angles are equal. So let's have a look. 180 minus 52 divided by 2 gives me 64. So this angle is 64, right? Then we're going to work out what x is, because again it's angles on a straight line. So we've got 180 degrees minus the 64 that we worked out for D1, okay? And that is going to give me 116. So x is equal to 116. Let's just go over that one more time. We had angles on a straight line here. 180 minus 128 gave me 52. 52 was our top angle in our isosceles triangle. We knew that it was an isosceles triangle because it was marked like that. That means the sides are equal in length. So we're going to say 180 minus the 52 and get that answer and divide it by 2. Okay, we end up with an angle of 64. So that angle there, BCD, would also be 64. But we are interested in x, so we're interested in this 64, and we're going to go 180 minus that 64 because it's angles on a straight line, and my answer is then 116. Right, please remember, if you have any queries or you're confused about anything, to send in your query or your question to grade9@worksheetcloud.com, and somebody will answer your query. Right, next one. We're now going to calculate the lengths of the sides. Let's see what this diagram looks like. Okay, not too bad. Okay, we go to calculate AD, right? That's not going to be too difficult because that one is 10 centimeters. It's opposite sides of a rectangle. How do we know it's a rectangle? We'll have a look. First of all, opposite sides are equal in length, and we've got one angle being 90 degrees, which means that all angles are going to be 90 degrees. Okay, so AD is equal to 10. We then have to work out AB. AB is equal to 24. Again, opposite sides of a rectangle. Now we've got to work out AC, which is diagonal. Okay, we've got that side and we've got that side. That is a right angle, which means that that is a hypotenuse. So we're going to use Pythag. Okay, AC, the hypotenuse, AC squared, is equal to AD squared plus DC squared. And we know the values of AD and DC. Okay, not too difficult. Okay, so we're going to keep AC squared, because we don't know, that's our unknown. 10 squared, which is the length of AD, the measurement of AD, and plus 24 squared, which is DC squared. I would recommend you use the calculator here. I don't know off the top of my head what 24 squared is, so you're welcome to use a calculator. And I know in grade 9, grade 8 and grade 9 you are allowed to use calculators. So 10 squared is 100, 24 squared, 576. Add those together, you get 676. Remember, it's 676 centimeters squared. We now need to square root that to get what AC is on its own. AC is now 26 centimeters. Okay, we square rooted 676 to get 26 centimeters. So your one diagonal is 26 centimeters. We now need to work out DE, which is half the other diagonal. We know that the diagonals are the same length. So if AC is equal to 26, it means DB is also equal to 26. So what is half of DB? You can even say half of AC. It's exactly the same because they bisect each other and they are the same length. We know AC is 26. Half of 26 will give me 13 centimeters. So half of the diagonal is 13 centimeters. DE, 13 centimeters. Should we go over that just one more time? Very easy in the beginning. I'm sure you thought, what is so difficult about this? But AD was 10 centimeters because it was opposite sides of the rectangle. AB was 24 centimeters. Pretty straightforward, opposite sides of the rectangle. Okay, we've got to work out the diagonal. We now know Pythag, so we can just implement that quite simply. AC squared is equal to AD squared plus DC squared. We know the measurements of AD and DC. We square them each. We get 100 and 576. We add those together. We end up with 676. Square root that to get to AC, which is 26. We know also, as one of the properties of a rectangle, that our diagonals are equal. So therefore, we cut this 26 in half to get half of a diagonal, and that is 13 centimeters. Please remember, guys, if there's anything you didn't understand about this, then email your query. Okay, but I'm sure you understood everything. Let's go on. Prove that triangle PRS is congruent to triangle PQT. Okay, we did that in the last lesson as well. Remember, that is your congruency sign. Let's have a look at the two triangles that we need to prove. We are told that PQ is parallel to RS. PQ is parallel to RS. We know that PQR, that angle there is equal to PRS. Q, that angle there, and Q1 is equal to P1. Okay, pause the video now. You try and work it out yourself, and then we will go over it together. Right, let's start. First of all, R1, let's find R1, there it is there, is equal to P2 because have a look, they are alternate angles. Okay, we don't need to know the sizes of them because remember what we're trying to prove is congruency. Okay, then Q1 is equal to P1 over there. Okay, given, we are told that, there we were told it there. Okay, the next thing is PR is equal to PQ, okay, because PQR and PRQ, so the triangle PQR is an isosceles triangle. Okay, let's have a look. PQR is an isosceles triangle because that angle and that angle are equal, and that means, oh sorry, that angle and that angle, that angle and that angle are equal, so that's an isosceles triangle. We'll get it right eventually, grade 9, sorry. And so we have, let's have a look, therefore those two triangles are equal because it's side, angle, angle. They're not equal, they're congruent. Okay, remember that's your sign for congruency. Alright, so let's just go over again. We had to prove that PRS, that triangle there, is congruent to PQT. Okay, now guys, please remember it doesn't look like it should be congruent at all, but you have to use what you are given. You are not using what you see. Okay, that is very important. Alright, we are told that PQ, let's just find PQ, PQ is parallel to RS. Okay, so we can use all our notes on what angles are according to parallel lines. You can use all those to actually figure out what equals what. Alright, so from there we figured out that R1 is equal to P2, that angle is equal to that angle. So we've already got angles, right, in the two triangles. Then we are told PQR is equal to PRQ. Let's look at it. PQR, there, that angle, PQR is equal to PRQ, that angle. Which means, if that is the case, then PQR is an isosceles triangle. Okay? Which means that PR is equal to PQ. PR is equal to PQ because that's an isosceles triangle. Those angles are base angles. Alright. So if PR is equal to PQ, that means you've got two sides of the triangles that are equal. That side is equal of this triangle to that side of that triangle. Okay, got it? And then Q1, let's find Q1, that one, is equal to P1, which is that one, which is two more angles in the triangle. So therefore, that even though it doesn't look like it, doesn't matter, that triangle and that triangle are congruent. Like I say to you, diagrams sometimes are very misleading. We can't go with what it looks like. We've got to go with what we are given. Okay, right. Well done, grade 9s. That was quite intense, some of those things that we put into practice. More practice if you do your activity, and then check your memo. Once again, if you have any queries, please email them through to grade9@worksheetcloud.com and somebody will get back to you. It's quite an intense section, but well done. We're nearly there. Thank you for listening to this lesson, and I hope you join me next time for the last lesson in this section. Well done, and bye-bye for now.